Make sure that you go in today at some point and fill out the parent contact quiz. I would appreciate that. It needs to be done today. Everybody good? Got to be done today. And then we're going to start on in behavior. And in behavior, it looks kind of hard, but it's really super easy. Okay. And I say that like seriously, it is so easy. Okay. So the degree of a polynomial, and I don't care about in the form of, let's just go with the degree of the polynomial, is the highest exponent in the polynomial. So all we're looking for is the highest exponent. So look at the very first example. It says state the degree of the following polynomials. Look at this polynomial. What's the highest power? 5. That's your degree. That's it. Degrees are easy. Everything is easy. You just got to remember what they're asking for. The next one, what's your highest power? 3. And then the last one, what's your highest power? 1. It's just a single x. Remember, they don't ever write it. It's just an understood 1 there. Okay, so that's degree. The leading coefficient of a polynomial is the coefficient of the highest degree. Sorry, I'll make that a little bit better. All right, so the next part says state the leading coefficient of the following polynomials. These are the same equations that we just saw, okay? So this one's degree 5, 3, and 1. These are the same equations. So you're looking for your highest power. We said this one was degree 5. The leading coefficient is the number in front of that x to the 5th. So what's the number in front of x to the 5th? 3. That's your leading coefficient. That's all you do. So find the highest power and then choose the number in front of it. So the highest power in the second one, make sure you keep the sign, was a 3. The leading coefficient is the number in front, which is -5. And then the last one, you said the power was 1, or the leading coefficient would be 2. Any questions on leading coefficient? You will have to identify those at some point, so make sure that you know what those are. All right, so then we're going to start with the in behavior, and I'll move it up in just a minute. In behavior of the graph of a polynomial f of x describes the values of f of x at the far right and the far left ends of the graph. So basically, you're telling me where it points. You're looking on the left, you're looking on the right. Tell me where it points, okay? So there are 4 possibilities. The first possibility is a graph that points low. Something happens in the middle, doesn't matter what it is. And then it ends high. So there could be all kinds of lumps and bumps in the middle. Again, there could be anything in the middle. It doesn't matter what. But all we're looking at is the end. That's why it's called end behavior. So we're looking where it points. So you split it kind of in half. So that's what I'm going to do. And we're looking at the left side and the right side. The left is always described by x goes to negative infinity. And the reason is because as we go on the x-axis to the left, it goes to the negative values as far as you can possibly go, which is negative infinity. On the right, it would be x goes to infinity. Those two will never change, okay? Those two will never change. What will change is your f of x part. So f of x tells where the function points. Sorry, it should be an arrow on either side. So if this one points down, where is it pointing to? How far does it go? Negative infinity. On the right, it points up, and I'm going to rewrite this so you can see it a little bit better. On the right, it points up, so it goes to where? Positive infinity. So this is actually how it looks. So on the left, it goes to negative infinity. On the right, it goes to positive infinity. Now, when it's multiple choice, it's actually going to be backwards, but we'll talk about that towards the end of what we're doing, okay? I like to do it this way to keep it consistent. Do it left and then right. F of x is the only thing that changes. The next one that you could have would point down, do something in the middle, and point down on the end. And again, it could have all kinds of lumps and bumps in the middle. As we get into our higher order polynomials, you'll see that there are multiple bumps and lumps in there. So then we do the same thing, and I'm actually going to do this one in the box. Where does it point on the left side? So that means left, x goes to negative infinity. Where does the left side point? Negative, it just points down. So the only two values that you're going to use are positive or negative infinity, and it's wherever the graph points, okay? Left and right never changes. F of x will change depending on where it points. On the right side, the right is done by x is positive infinity. Where does the right side point? Come on, guys.
Negative infinity.
Thank you, thank you. Appreciate that. Is everybody okay with what I'm talking about? Y'all aren't answering, so I don't like it. I mean, this is an easy concept, and if you're not answering, it worries me. Is everybody okay? All right, start answering me, okay? I like to hear y'all talk. All right, the next one would point this way, finish this way. So on the left, x goes to negative infinity. That's always the left. Where is this graph pointing on the left?
Positive infinity.
Perfect, thank you. On the right, which means x goes to infinity, where does this graph point? Negative infinity, perfect. Y'all realize the faster we do these notes, and I'm not trying to rush you through the notes, but the longer it takes you to answer easy questions, the less time you have to do your homework in here. So those of you that are sitting in here, you want to not have a Friday night homework assignment, let's get on with this. Okay, not being mean, just saying. The last one that we could have would point up on this side and point up on the other side. To represent the left, x goes to negative infinity. Where does this left side point? Positive infinity. To represent the right, we go to positive infinity. X goes to positive infinity. And what is it doing on the right side? Positive infinity. So remember, left and right will never change. The only thing that will change is your f of x. Left goes to negative infinity. Right goes to positive infinity, and you just use your x. Okay. Okay. Again, these notes look long, but they're really quick and easy. Okay. Any questions on the first page? If you're struggling, it gets easier as you go. Just keep paying attention and keep working. All right, describe the end behavior of the following graph. So notice this is like a big W. It's not just a straight U like we're used to. So like I said, anything could happen in this area right here. We don't care. What we're looking at is this and this, the two ends. So the first end we're going to talk about is the left side. So we represent that by x is going to negative infinity. Where is the graph pointing on the left side?
Infinity.
Up to positive infinity. On the right side, we represent that with x goes to infinity. Where does f of x go? Also infinity. That's it, y'all. That's literally all we're doing. Okay. Again, doesn't matter what's in between. All we're looking at are the two ends right here. So on the left, where does it point?
Negative infinity.
Perfect. Now remember the left is x goes to negative infinity. On the right, x goes to positive infinity. Where does the right side point? Positive infinity. That's it. That's all you're doing. Okay. All right. So then this next chart kind of puts everything that we've talked about today in perspective, okay? It puts it all in one question. So if we look at the first one, it says, please list the degree, the leading coefficient, the end behavior. The end behavior I'm going to put up here, okay? Up here. All right, so we're going to talk about it. What is the degree? Remember, the degree is the highest power. What's the degree?
3.
3.
What's your leading coefficient?
1.
Good. All right, so here's something that you need to know, and I'm going to come down here to the bottom and write it out. When you look at the degree, or the highest power, it will be one of two things. It will be an odd number, or it will be an even number. Okay. Odd means opposite. What does that mean? If it's an odd power, like we just got a 3, an odd degree is 3, that means it points in opposite directions, okay? So they don't both point up and they don't both point down, they point opposite. Doesn't matter which way, they just point opposite. But if it's even, like x squared, x to the 4th, x to the 6th, those make u's and w's. So they point in the same direction. So if it's even, they point in the same direction. And if you need to put direction on there, that's fine. Okay, so those are the two things you're looking for out of degree. Once you figure out if it's opposite or if it's in the same direction, the next thing you need to look at is the leading coefficient. If that leading coefficient is negative and it's an odd power, so opposite directions, and it's negative, then it's decreasing. That means the left will be pointing up and the right will be pointing down. So you don't have to graph these, okay? If you can remember this little cheat sheet chart, and you will by the time we finish today, okay, then you will be good to go. Can you graph them? Sure, put them in your calculator if you don't remember this, and then you can see where your ends are. If it's a positive number and it's opposite directions, it will be increasing. And I always just use linear because you guys focus on linear a little bit. You can see it a little bit more. So if it's positive, the left side is going to be going to negative infinity and the right side will be going to positive infinity. All right, so if they point in the same direction, so think about x squared. If I have the function x squared, what shape is it? And how does it point? Yeah, it's a U shape, it points up. So if it's negative, what happens? Yeah, so that negative turns it over. So both f of x's will be negative infinity. And if it's not negative, it's positive, then both will be positive infinity. Does that make sense? Everybody get it? All right, so we're going to know that now. So you can look at that cheat sheet the whole time. It's going to go away on the screen, but you can look at it the whole time we're doing this. So on this first one, we had a degree of 3. Is that even or odd? Odd means opposite. We had a leading coefficient of 1. All we need to know is it positive or negative? Positive. 1 is positive. So opposite directions, and positive looks like this. So now when we write our end behavior, we can do it without you graphing it, okay? So on the left and on the right, we're checking out what f of x does. So on the left, what does it do? Here's your example. Negative, infinity. And on the right, it's pointing up. It goes to positive infinity. Can you graph it? Of course you can. If I go into my calculator, I got some stat stuff in there, sorry. X to the third minus 2x squared minus 5x plus 1. It's just taking me forever to put it in there. I'm going to zoom 6. There it is. So you can see on the left side it points down and on the right side it points up. So if you can't remember the little cheat chart, that's okay. Graph it and you'll know, okay? All right, look at your next one. What's your next one? What's your highest degree? 3. What's your leading coefficient on that 3? -2. So this is odd, which means opposite directions. -2 means it's going to be decreasing, okay? So it looks like this. So when we write our left and our right, on the left, this graph is pointing up, so it's going to be what? On the left, on the right, it is pointing down, which means negative. So you don't have to graph them. It makes it a little bit faster if you'll remember that chart, okay? And we're going to do a bunch of them, 12 of them, so we'll be good. All right, your next one, what's your degree? Leading coefficient. An even means they point in the same direction. A negative means they point down. So it looks like this. So we do the left and the right. And they both point where? Down to negative infinity. That's it. That's all you do, guys. That's all we're learning in this little section. I'm going to go down to the one below it and go backwards this time so I can keep those up while we're doing it. What's your highest power? What's your leading coefficient? 1. There's no number in front of x to the 4th, so there's understood 1. 4 is even, which means it points in the same direction. 1 is positive, so that means it points up. Sorry. So it looks like a U. On the left side and on the right side, it points to what? Positive infinity. Very good. Zoomers, you got the next one. What's your degree?
5.
5. What's your leading coefficient? Somebody else?
1.
1. What does that tell you? Somebody else?
It's going to be increasing.
Okay, because it's positive, but what about it?
They point in different directions.
Different directions and increasing. Odd and increasing. So opposite and increasing. Somebody else on the left. Where does the left side point to?
Negative infinity.
Perfect. And then one more person. Where does the right side point to?
Positive infinity.
Thank you. Perfect. Good job. Last one on this page, and then we got like 6 more on the other page. Okay, no big deal. Highest power?
4.
4. Great job. Leading coefficient,
-1.
which means how do they point?
The same.
The same direction.
The same and down. Perfect. So that means on the left and on the right, they both point where? Negative infinity. Perfect. That's it. Any questions on these 6? Everybody doing okay? Again, they're not bad. This is usually the easiest part of the test. Okay, it's not bad. Our next unit's my favorite one, if that makes y'all feel any better. Not this one. This is not my favorite. All right, here we go again. Highest power,
4.
leading coefficient. What does this one look like?
2.
Good job. Both pointing up. So on the left and on the right, they both point to what? Positive infinity. Girl, you on it today, I hear you. All right, next one, what's it say? Degree?
5.
Yeah, it's okay. Leading coefficient?
-1.
What's that mean?
They point in
Again.
different directions.
Different directions and down. So I heard down in here and then different directions on Zoom. So again, we go left to right. That's how we read. The left points where? Positive, because it's up. And the right points to negative infinity. Are y'all good, or we need to keep on? Zoomers, are you good?
Yes, ma'am.
All right, let's drop down to these. This is the same thing that I wrote in your cheat chart. So if you don't understand what this is, it's the cheat chart, okay? So the left and the right end behavior of all even degrees. So I told you even goes in the same direction. That's your cheat chart. The left and right end behavior of all odd degree goes in opposite directions. The right end behavior of all polynomials with a positive leading coefficient. So it doesn't matter if it's even or odd. If it's positive, the evens are pointing up or they're increasing. So what it's talking about are these two ends. Always go to positive infinity. The right end behavior of all polynomials with negative. So negative will look like this. Then it's just talking about the right side. We'll go to negative infinity. All right. Any questions on this page? This next one, we're going to skip that box because it's the same exact thing that I just said and I showed you in the cheat chart. So we've already done it. So I'm not skipping it like I've already done it. Okay. So I'd rather tell you the cheat chart when we start than make you figure it out later and have to graph all those. So we're not doing this and we're moving on to the examples. It just says identify the end behavior of 8x cubed minus 2x. So the two things that we need are the degree and the leading coefficient so that we can kind of sketch it out and see it. So what is the degree? 3. What does that tell us?
Odd.
So it does what? Opposite directions. Odd and opposite. Think about those O words. This mask is tickling my nose. Leading coefficient is?
8.
8. All we need to care about is positive or negative. Is it positive or negative?
Positive.
So that means it's increasing. So it's going to look like this. Opposite increasing. So then when we write our left and our right, we know exactly what it looks like. What happens on the left? It goes to negative infinity. What happens on the right? Positive infinity. That's it. So you don't have to have the graph. You don't have to know anything. Same thing that we've been doing. It's the same thing. All right, be careful on this one. We need the degree and the leading coefficient. What's your degree? Good. Make sure you get the highest power. It's an even, so that means it's pointing in the same direction. What's your leading coefficient? That means it is decreasing. You can put negative, decreasing. I don't care as long as you know it points down. So same direction and down means that when we look at it on the left and the right, where is it pointing? Negative infinity on both sides. Perfect. Just a couple more, we'll be done. You don't have to write this super fancy, like you can be a little bit squiggly with it. I'm not writing very pretty today, so sorry to write it fast. All right, everybody got it? We good? All right, identify whether the function graph has an odd or even degree or a positive, negative leading coefficient. Justify your answer. So what is this one? Does it have an odd or even degree?
Odd.
Odd.
Is it odd? Opposite directions. That's your justification right there. So your answer is odd. Your justification is that it's opposite. Is it positive or negative? Why is it positive? It's increasing. That's your justification. That's it. The next one, is that odd or even?
Even.
Why is it even?
Same direction.
Same direction. Positive or negative?
Negative.
Why?
Or pointing
Points
down.
down. Perfect. That's it. All right, so then the next one wants you to write a function. There are 4 million billion functions. That's the worst number I could ever pick, but there are an infinite amount of functions that you could pick that would work on this. So there are like 34 of you in here. I could get 34 different functions, but I'm looking for the two things that we've been talking about, the degree and the leading coefficient, okay? So it says, give an equation of a polynomial f of x with in behavior of, on the left, f of x goes to negative infinity. So on the left, it points what? Down. And on the right, it points down. So it looks something like this. What does that mean our degree needs to be?
Even.
Even. Remember, odd is opposite directions. Even is the same. And then what does our leading coefficient have to be?
Negative.
Negative. Good job. You can make any function as long as your largest power is even and your leading coefficient is negative. Y'all, there are an infinite amount of possibilities here. I'm gonna make it as simple as possible. Give me a negative number. -6, I heard. X to the, give me an even power to the second. We could do any negative number and any even power. You could even write a plus x plus 4 out here, but you don't have to have it. Y'all see what I'm saying? So there's lots of stuff you could do as long as your leading coefficient and your degree is what it's supposed to be. One more. On the left, it goes to negative infinity. That means it points down on the left, and on the right, it points up. Down on the left, up on the right. So what does our degree have to be? What kind of number? Odd. What does our leading coefficient have to be? Positive, because it increases. So f of x equals, give me a positive leading coefficient. Any number. 5. X and an odd power. 3. That's it. You can put a bunch of stuff behind it. You can change the number in front as long as it's positive. You can change the power as long as it's 3, 5, 7, 9, 11. It doesn't matter. All right. Any questions? Okay, so let's look at our quiz for a minute and let me explain the answers to you. Because if you look, they're backwards. Does everybody see that? They're backwards. So they just write their f of x first. So if we look at this first one, I'm going to help you out with this first one. We have a degree of 4, which means
Even.
It's even, which means what?
Same direction.
Same direction. What's our leading coefficient? 1, and it is positive, so that means it points up. So we've been writing it like this. And you said it points up. So whatever's with the x goes to negative should be a positive. So if you look, they write it backwards. X goes to negative, then there's a positive. So that one's okay for now. Negative, negative. Is that one okay? No. All I'm looking at is the left. Negative, negative. Is that okay? This one says negative, positive. Is it okay? Yes. So then on the right, you said it goes to positive. So the second one is on the right. That means the right says it's negative. Is that one the right answer? No. This one says positive, positive. Is that the correct answer? Yes. Take your time with these because it's real easy to miss those signs, okay? This should be a free 100 for you guys, but you've got to take your time and check those signs out, okay? And everybody should get number 1 right. If they get number 1 wrong, I'm gonna be real mad at you. Is everybody good? All right. Zoomers, if you don't have any questions, I'm gonna stop sharing, stop recording.